And we are back. What is up, guys? We're cruising through this playlist. If you made it this far, I want to congratulate you already because we did most of the hard stuff already. So hopefully smooth sailing for the rest of this playlist. In this video, we're going to cover global actors, probably one of the less common topics in this playlist, but global actors are basically actors, which we learned in the last video, but global. So we can access the actor from outside of the actor. So if we want to put other functions, other classes, other structs onto that actor, we can do that using a global actor. It goes without saying here that if you don't know what actors are, watch the last video or the last two videos before this one. There's no sense in learning about global actors if you don't first understand actors. And yes, if you were wondering, the @main actor is a global actor. We're going to take a look at that as well in this video. And we are back. What is up, everyone? Welcome back. I am back in Xcode. Where else would I be? And we're going to write some more code for this video. We're going to cover global actors, which has been covered a couple times on YouTube, but I think there's still a lot of confusion about them, why we use them, why we want them, and they're not that common. So let's jump into this. This is going to be a lot of fun. Let's right-click the navigator, create a new file, Swift UI view, and let's call this one Global Actor Bootcamp. Let's go ahead and click create, jump inside here, click resume. This video is going to have a lot less setup than the last one, which I'm excited for because sometimes I feel like I am boring you guys with the setup in these videos. It is just so hard to explain some of this stuff without examples. Otherwise, we're just going to talk abstract all the time. Anyway, in the last video, I did not include view models. I often do include MVVM and view models. So in this one, let's go back into that MVVM approach. So this view is going to have a view model. Let's create a class. Let's call this one Global Actor Bootcamp View Model. Conforms to observable objects. Open the brackets. Let's initialize one in our view with it at state object. Private var view model, set it equal to a global actor bootcamp view model. Let's keep this super simple as well. In the view model, we'll create an @published var. Let's call this data array of type. It'll be an array of strings, and we'll set it equal to a blank array for now. In our body of our view, let's create a scroll view. Let's create a scroll view. Let's give it a vstack, and let's do for each. And let's loop on. We're gonna loop on these strings, which means we need that ID completion for the hash value. So we'll loop on the view model.data array. We're gonna use the \self to reference the hash value of each string. And the content, let's just use the text. Let's put that string on the screen. I'll give it a font of headline just to make it a little thicker. And when this view appears, we're gonna give it a task. And then we're going to run some asynchronous function in our view model. Let's say func get data. Let's make it asynchronous and open the brackets. Let's call that from our tasks. So we will await view model dot get data. All right. Click resume. This should be blank for a second. All right. Now, in the last couple videos, 2 videos back, we learned what actors are. Well, we learned specifically the difference between classes and actors. In the last video, we looked at what is the problem actors are actually solving. And in this video, we're going to just do a very simple actor, which is probably a bit of a realistic example of how we would use an actor in our app. So oftentimes our app's going to have a view. The view will have a view model. That view model will reference some sort of shared data manager that is shared across probably multiple views, multiple view models. So let's create that as an actor. And we're going to call this maybe my new data manager. My new data manager. And so my new data manager is going to be used across multiple classes, multiple structs, multiple views, whatever. It can be used anywhere across our entire app, and we don't have to worry about the thread safety of it because we know it's an actor. Anytime we are going to get into that actor, we're going to await on it, And that's the beauty of the actor, because it is thread safe. We don't have to worry about any thread problems. But for right now, let's just get a reference to the manager in our view model here. So we'll say let manager, and we'll set it equal to a new instance of my new data manager. Inside here, let's create a function that says maybe get data from database. Of course, we're not going to actually set up a database here, but this function will return us an array of strings, right? That's what we need in our view. So in here, let's just return, and then we'll just do 1, 2, 3. Cool. Let's call this function from our getData function. So we'll call manager dot get data from database. So we'll say let data equals that, and then we'll set self.data array equal to the data. If I click resume on the canvas, and of course we need to await to get data from database. Now I want to point out here one more time that this function that we created could have been asynchronous, but this function itself is not actually async. But when we call it from down here, it still is async, right? If I look at it, right, if I go to type it in here, I can say dot get data. We can see that it is still async, and it again is asynchronous, not because the function is marked with it, but because it's in an actor, and that is an asynchronous task to get into that actor. So that means we need to await on it. If I click resume on the canvas, hopefully get 1, 2, and 3 popping up on the screen here. There they are. Cool. Nothing new. This is a pretty standard setup in our app here. We have our view. Our view has a view model. Our view model is referencing a data manager, a data store, which is either going to be a class or now more likely it's going to be an actor. But in this video, we're talking about global actors. And the question firstly is, what is a global actor? Why do we even need a global actor? And in a simple app like this, we don't need global actors. In really complex apps, you might. But let's just imagine in this function in here, maybe we were doing some like really heavy and complex tasks. I shouldn't use the word task. Let's just say like methods. So maybe there's a lot of like really heavy lifting that has to happen in this function. And we know right now we're calling get data from the task that is directly on the view, which means that the task is running on the main actor. And so when we get into this function, all of this is going to be running on the main actor or the main thread. And a lot of times you don't want your main thread to be clogged down with really heavy, complex tasks. Now, if this is all we were doing, I would not be needing any kind of global actor. But without a global actor, when we just have an actor like this, the only time we actually get into the thread safety of this actor is when we await to get into it. And in the last video, I showed you how we could use the non-isolated keyword. If I add non-isolated into a function inside an actor, we are then declaring that this function does not have to be isolated to the actor. But what if we wanted to do the reverse? What if we wanted to take a function that's not in the actor and then isolate it to the actor? How would we actually do that? Well, that is the whole purpose of a global actor. So how do we get data, this function here, to be actually part of the actor that it is obviously not part of by default? So in order to make this actor a global actor, we basically need a shared instance of this actor that is outside of the actor itself. So a little confusing. I'm going to Command Shift O, bring up the open quickly, and I'm going to type in global actor and jump to the docs here. In Apple's docs, which probably could be a little bit better, but we can see that this type represents a globally unique actor. So there's only one of this type of actor across our app that is used to isolate various declarations anywhere in the program, blah, blah, blah. When using this declaration from another actor or non-isolated code, from using this shared global actor from outside of that actor itself, synchronization is going to be performed through the actor instance, the shared actor instance, to ensure mutually exclusive access. So the shared actor instance, and if we look at the protocol of Global Actor, it requires us to have a static var shared, a shared instance of the actor. And then every time we are going to use this actor, we're going to access it through the shared instance. So having a shared instance is the same thing as a singleton pattern. Many times throughout this course and other courses on my channel, I have talked about how I don't really like to use singletons, and you probably should not as well. In the advanced course on my channel, I have an entire video on dependency injection and how that is a great solution to using these singletons. However, when using global actors, we absolutely have to use this singleton technique. It is literally part of the protocol. And so in this situation, I do recommend using singletons. Let's actually use one in our app now. We're going to jump back to the code here. So we have this actor. And right now, the only time we can access the isolation from this actor, anytime we can get into this actor, is by awaiting when we get into the actor. And I showed you guys in the last video, the word non-isolated is a nice keyword. Non-isolated is when you can mark functions and variables and mark them as being not isolated to the actor that they are in. So this function is no longer isolated to this actor. But in this example, we actually want to do the exact opposite. We want to take a function like getData down here that is already not isolated to this actor, and we actually want to take this function and make it isolated to this actor. And then the question is, how do we do that? We do that with global actors. And so what we'll do is somewhere else in our code we'll create, and I think we can use either a class or a struct, maybe even other types as well. Let's use a struct for this example. I'm going to create an @GlobalActor, and I'm going to call, and it will be a struct, and I'm going to call it, let's call it my first global actor, open the brackets. Now, as we just saw, in order to conform to global actor, we need a shared instance of the actor. So in here, I'm going to create a static var shared, just like the protocol required us, and I'm going to set it equal to an instance of my new data manager. The caveat here is that anytime we access my new data manager now, we want to do it through this shared instance. We do not want to access this directly. So what we're going to do is in our code down here where we have my new data manager, instead we're going to reference my first global actor dot shared. And we can see that that's returning us my new data manager. So let's make sure it's still working. I'm going to add maybe 4 here, 4, and click resume. Make sure we can still get number 4 on the screen. Looks like it's still working. And now, what does this @GlobalActor actually do? Because nothing has changed in our code really. Well, because we marked this as an @GlobalActor, well, in the same way that we use the non-isolated keyword, we can now use @MyFirstGlobalActor to purposely mark things isolated to the actor. So for this getData, if we want to actually isolate it to this global actor, we can do @MyFirstGlobalActor. And if I run it one more time, let's add maybe the number 5 here to make sure it's still working. 5 pops right up. And so now we have the same function, except it's actually running on the actor here. And a lot of people will put the declaration on a separate line from the function. I actually like to put it on the same line, but that is just your preference. And just to prove that we are actually on this actor here, firstly, I'm going to comment it out. Let's make this function not asynchronous, and instead in here we will jump into a task. And now let's call getData from our code. So let's just do it from maybe, let's do an onAppear, and we'll call viewModel.getData. All right, so here we're just running on the main thread, a regular function, not an asynchronous function. And then in this function, we're jumping onto a task. But now if we actually mark this function as being on the my first global actor, we're going to get this error message. And it's literally telling us that this function, getData, is on a global actor and is isolated to that instance. And so we can't just access this function unless we're in one of those concurrent contexts. So of course, if we were in a .task, we can then of course call getData. But of course, even though we're in a task, calling getData here, which I'm waiting for the compiler. But of course, even though we're in a task and we're calling getData, and even though getData is not marked as asynchronous, this is going to be an asynchronous method. And that's because we need to await to get into that actor. So again, we are going to await here. And that is just proof that this function is now running on my first global actor. And so that is the whole gist of global actors. Most of the time, you're not going to need them. But occasionally, if you have some big shared global actors in your app, and you want to take functions that are not in the actor and put them on the actor, this is the approach to do it. I'm not 100% confident if struct is the right method here. I think it's fine. I've seen other developers do it. Some other developers make this a class. And if it's a class, you actually need to mark it as final, which means no other class can inherit from this class. It's not something that I've done very often on this channel. But if I run this, this should still work the same way. Looks like it's still working. So final class or a struct, I guess it depends what else you're doing inside this actual object. But either way, global actor works the same way. We get our actor, we create a shared global instance of that actor, and then we can use it. The important thing to note here is that if we are making a global actor, we want to make sure every time that we are accessing this actor, my new data manager, we are doing it through the shared instance. So here we are doing it through my first global actor.shared. We do not want to create a global actor and then create other instances of the actor, and now you have this instance in your app and this instance in your app. If you're making a global actor, it should be one single global actor shared instance of the class. All right, that's enough of that spiel. Before we wrap up here, I do want to talk about the main actor. Now, I've used this a bunch of times in this course because you can't switch on to the main thread without running on the main actor. But the main actor is actually a global actor just like this. So in the same way that we can mark functions or variables on my first global actor, we can also mark them on, I'll comment this one out, the main actor. And it is literally the exact same thing, except this one is already created for us. And of course, it is the main actor being the main thread. So if there's anything in your app that you want to ensure is being done on the main thread, just mark it with a main actor. So a great use case of where to use main actor is, well, in this sample right here, and I'll put this back onto the global actor. In this sample right here, we know we are on this global actor, we're running this task, and then we're going to update our data array. And we know this data array, this published variable, is affecting our UI here. And anytime we want to update the UI, we need to go back onto the main thread or the main actor. So far in this course, I've been calling await main actor.run, and then we are back on the main actor and we can update our UI, and that's perfect. But as you'll notice, when I did not do this, we didn't get any kind of compiler warning here that we needed to be on the main actor. If we ran this in our app, we'll get that purple warning, which we saw earlier in the course, that, hey, you need to be on the main thread. But right now, in our compiler, we're not getting any red warnings in our code. But we know that this data array is affecting the UI directly. And anytime we update this published data array, it needs to be done on the main thread. So how do we isolate this variable to the main thread? Well, we declare this variable as being part of the main actor. This variable is isolated to the main actor now. And the magic of this, my favorite part, is that when we declare something as being on the main actor, we can start getting these compiler warnings directly in our app. So now we know this has to be on the main thread, and so does the compiler. And now it says, well, you can't update this unless you are on the main actor. And so if we switch back onto the main actor now, we know our code's going to run perfectly and without warning. In the same way that we mark something as being on the main actor here, we can also mark it as being on another actor. But of course, we would never want to do this because we know this is updating our UI. Our UI needs to be updated from the main actor. So I'm going to keep that as a main actor. Last two things I'm going to touch on is, firstly, I'm not sure. I think you can put the main actor after the other declarations. I don't think it makes a difference. I'm not sure which way is better, to be honest. Probably doesn't make a difference. But the last thing I do want to leave you guys with is sometimes, occasionally in your app, you end up into situations where maybe you have a whole bunch of methods in like a class that are all going on to the same actor. So for example, we're not going to do this, but imagine we had a whole bunch of methods here that were all had to be on the main actor. And this is kind of common in like view models or something. Maybe you had a whole bunch of different data array 1, 2, 3, 4, and maybe they all have to be on the main actor. Well, it might get really annoying to then have to mark main actor, main actor, main actor for all of your variables, all of your functions. I wish there was a way to just mark this entire class as being on the main actor. Well, we can, and we do that very simply by marking the class as @main actor. So by doing this, everything in this class is automatically going to be isolated to this actor. And we can use my first global actor here. We can use any global actor. Commonly, I would say it's probably the main actor. Although personally, I'm going to prefer doing these @main actors more often than not. It just gets a little confusing when you mark a whole class as an actor. But I want to let you guys know that you could do that. So you can mark an entire class, an entire struct, as being on the main actor or on any other global actor. And the beauty of that is, firstly, that you don't have to call @main actor every time. And if you ever did do that, but then you had functions like this one where you don't actually want them to be on the main actor, you can obviously mark them as on their own actors, like we did here. Or taking a keyword from the last video, we can now mark these as non-isolated. This again is going to mean that although this entire class is isolated to the main actor, this function does not have to be isolated to that actor. All right, that is my video on global actors. I hope that makes a little more sense to you guys. Global actors are not super common. You probably don't need them in the majority of apps, or at least smaller apps, but they're pretty cool. They're pretty interesting. Actors are obviously super powerful, and we are mostly done covering them. So I hope you guys are getting a little more comfortable with actors, how to use them, just how powerful they are. Thank you guys for watching. As always, I'm Nick. This is Swiftful Thinking, and I'll see you in the next video.